All right, algebra students, in this video we're going to talk about transformations first, and then we're going to graph some more absolute value equations, and hopefully you'll get to see some reasons why things move the way that they move and all that. So in a previous video we have covered how to graph the absolute value of x. We used a table for that, if I do remember correctly, but for this one we're going to go into and start talking about exactly the way that these things move and all that sort of stuff. So for our graph anyway, if you remember, the absolute value of x, it started off at the origin and then it went up 1 over 1 for a few points, and then we would kind of take it up that way. Oh, that kind of got off kilter here. That's a little bit better. And then we went up 1 and then left 1 in the other direction. And so our parent function, where it is the absolute value of x, looks something about like that, okay? Where on the right-hand side of the graph, it has a positive slope of 1, and on the left-hand side of the graph, it has a negative slope of 1. So what the directions tell us to do, it says to use your graphing calculator, or you can use Desmos if you need to. Graph the following functions and then compare to the parent function and give a brief description. I think it would be acceptable. You guys could probably do that without me, so pause the video, and if you want to, you can check in and see what I have to say. I think that if you do number 1, then you'll see that this one is shifted to the left 2. I think that if you do number 2, then I think that you'll see that this is shifted to the right 2. I think if you do number 3, then I think you'll see that this is shifted up 2. And I think that if you do number 4, then you'll see that this is shifted down 2. Now, it gets a little bit hairy when you're talking about 5, 6, and 7. They definitely they have some relationships based upon them. But generally speaking, you would say that this one is stretched, number 5 anyway, that it is stretched vertically. So it has a vertical stretch. And then by 2. I ran out of room here. So by 2. So it is stretched vertically by 2. It's like you're pulling the y-axis and you are stretching it up 2. Okay? And that V shape becomes more narrow. Okay? For number 6, it is like you are taking it and it has a vertical compression, or sometimes people say that it is a vertical, not stretch, but a shrink. You could say either way, but a vertical shrink would work, or vertical compression. And you would say that this happened by 1/2. And it's because of that 1/2 out in front. And the parent function, it looked like it got smushed, and it got that V is now wider. Okay? And then last but not least, if you put a negative out in front there, then that thing gets reflected across the x-axis. Okay? So you just using those things and playing around with some stuff, you can come and make up your own rules. I also have them typed up for us. If you have either absolute value bars or you see parentheses or something like that, inside those things, if you're adding or subtracting to that x value, then you are shifting it to the right or to the left. Okay, and if it's positive, it always goes backwards by the x. So if it's positive, then you shift it to the left. If it's negative, then you shift it to the right. Okay? If it's outside those absolute value bars, or it's outside the parentheses, then it's up or down, and those are true. So if it's positive, it goes up, and if it's negative, it goes down. Okay? Generally speaking, if A is greater than 1, we would call that a vertical stretch. Now, here's what I want you to change on this worksheet. If you have some sort of number out in front, this is what that's talking about, like that 2 or the 1/2 or whatever it is that it may be. If that is not just when it's less than 1, but also I want you to sneak in that if it is between 0 and 1, that is when you have a vertical compression. Okay? So when it is between 0 and 1, so try to include that in this inequality right here. So it's when it's between 0 and 1. Okay, so that's like when we had that 1/2. That's between 0 and 1. If you go on the other side of 0, then you start talking about negatives, and that has its own rule, because when it's negative, then you flip it across the x-axis. Okay? Now, I think that it makes sense to kind of go over this using some and graph some more of these. So let's try this on the next page. On the next page, we start off, what is the parent function of an absolute value equation? We've already done that. That was f of x is equal to the absolute value of x. Now, I think that it would be good for you guys to go ahead and try these out on your own if you can. Okay, and try to see what you think that it would be. Now, you could graph it if you wanted to, but you shouldn't have to now. Okay, because on A, and if you have graphed it and you've paused it, then unpause it. I would say this one goes right 5. For letter B, this one goes up 9. For letter C, it is reflected across the x-axis. For letter D, now we've started to do a couple of different things. First of all, this one is shifted down 2. But then it's also got a vertical stretch by a factor of 3. Okay? On letter E, we would say that has a vertical shrink by 1/4. But then we also say that it moves left 6. So left 6 units. Okay? And then lastly, for letter F over here, first of all, this one is reflected across the x-axis. It's also moved left 7 and down 2. So there are the basic transformations that you have. Now we're going to move on, and we're going to deal a lot with today. We're going to deal with absolute value equations. And in Vertex form, it looks a lot like this. Okay, so it's f of x is equal to a, and then you've got your absolute value bars, x minus h, absolute value bars, and then plus k. Okay, the vertex of this would be at h comma k. Okay, so you take the opposite of whatever x is, of whatever the h is, I'm sorry, in your formula, and then k is just straight up. So in our formula, it was minus h. The vertex, though, would be at h comma k. And then a is the slope on the right-hand side, and negative a is the slope on the left-hand side. Okay, so that helps us out a lot to be able to tell how much of a stretch or a shrink it should be. Okay, so the rest of this is just some examples of whatever. Our vertex of this of number 1 would be at 2 comma negative 4. So let's plot that point over to negative 4. Put down there. A is 1, so we go up 1 over 1 on the right hand side, up 1 over 1 on the left hand side, and then you make your lines. There you go. All right. Number 2, our vertex, I think it's helpful to write this down at least until you get comfortable with it, would be at negative 5 comma 0. So we go left 5 and we put a dot. Now on this one, 1, 2, 3, 4, 5, make sure I counted right. On this one though, it has a vertical stretch, and so instead of going up 1 over 1, we're going to go up 3 over 1. And then we're going to go up 3 and then left 1 on the other side. Okay, so up 3 over 1. We'll continue to make some more dots. And so this one, it has a lot skinnier of a V. Okay, hopefully you see that. Flip it over on the back. On the back side, again, more just the same. We're going to go left 1 and then down 2. So left 1 and down 2. There's our vertex. So on this one, for number 3, we're going to go up 2 over 1 because it is a vertical stretch by a factor of 2. And we can continue to make some more dots. Up 2 over 1, up 2 over 1. And so you see our V right here. And there you go. So the A, that number out in front of the absolute value bars, that tells you where or how far up and over to go, and you count it just like you do slope. Okay, it's really very, very similar. Okay, make sure I put that one in the right spot. Number 4 would be at right 6 comma 0. 1, 2, 3, 4, 5, 6. Okay, the key thing to number 4 is that you know it should be facing down this time instead of facing up. We're still going to count up 1 over 1 or down 1 over 1, however you want to, because the slope's going to be 1. This time, though, I'm going to go down 1 over 1 on the left-hand side because I want to go down from that point. And I'm going to go down 1, right 1 on the right-hand side. So my V opens up kind of like this. Okay? But it goes down for sure, right? Number 5. Okay, number 5, we have a vertex at -1 comma -1. So it's going to go like that, right in there. Now on this one, we have our first fraction in there. But if we treat it just like it is a linear equation, then it's a lot like counting those slopes on there. So it's up 2 over 3, and then up 2 over 3. And so this guy would go out this way. I did not do my other side. Up 2 and then left 3. Up 2 and then left 3. So it goes out like this, and it's a little bit wider than our normal equation or our normal parent function or whatever. Okay. On number 6, we'd start off. It's at 0 comma 7. So up 7. We put a dot there. Now on this one again, I want to go down. Okay. So I'll go down 4. I'm sorry, down 3. Down 3 and then right 4. Down 3 and then right 4. I'll go down 3 and then left 4 on my other side. And so we get to something kind of like that. Hold on, I counted something wrong. I think where I made the mistake was at this point right here. So let me try this left-hand side again. Down 3 over 4, down 3 over 4, and there we go. 1, 2, 3, 1, 2, 3, 4, right there. Again, made another mistake. Sorry about that. So let's connect our dots. And there we go. All right. Now, because we've got more functions that we can deal with now, we can actually incorporate more piecewise functions, which are fun. So we're gonna graph this top one. Okay, I'll do it in red. We'll go up 2, put a dot, and then we go up 4 over 1. You can also go down 4 over 1. And I'm really looking for this one. I'm going to go down 4 again. I'm really looking for this one where x is less than -1. Well, at -1 was at this dot that ends up being right here. So I'm going to put a circle there, okay, and then it's everything to the left of that circle. So it's my line is going to go this way. Okay, so instead of drawing the whole thing, I don't have to. And I'm going to erase these other dots. Now that's the top one. The bottom one is this dude right here. I'll do it in blue. Now typically speaking, you'd go left 3 and it would be on the axis there. So it would be like right there. And then it is down 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And then it would be the same thing on the other side there, so it would kind of look like this, and it would be a V-shaped thing like that. But I don't need the majority of those. Really, all that I need is from that -1, and then everything that's greater than that, so to the right-hand side of that. So it is this part of the line that would go right here, and I can leave that as a closed dot because it included that -1 right there. And so it's everything from that point over to the right-hand side because it was greater than. Okay? Let's try number 8. Number 8, another piecewise function. So on this one, this top one, I'll do it in red. Okay? So this one has a vertex at left 1 and then up 5. 1, 2, 3, 4, 5. Put a dot. And then it's a -1 for my A value, so I'm going to go down 1, right 1, and down 1, left 1. So because it's going to point down this way. Now I'm really concerned about this graph where it is less than or equal to a -4. Okay, so I look at where x is -4, 1, 2, 3, 4, and that is from this dot right here. And then it's everything to the left of that. And so I'm going to draw my line that direction. All these other points I can get rid of. Okay? Now, my middle one was basically y equals 3. Okay, y equals 3 would be from this guy over this direction. But I'm really concerned about from where it goes from -4, that's where I have that open circle, over here to a +2, so from right here. So if you wanted to, you could continue to draw that line and you could erase what you don't need. But this is exactly what I do need, from -4, and I have an open circle there, over here to a +2. Okay, so from -4 over here to +2. That line does keep going in both directions, but I get restricted right here because of my domain. All right, now, last but not least, I got -x plus 7. So I go up 7, I put a dot, and then it's down 1 over 1. And then it's down 1 over 1, and so I continue to make dots this direction. Okay? Now, on this one, it needs to be from where it's greater than or equal to 2, and that would be at this dot right here, and then in this direction right here. I can get rid of these other points. And there we go. There is your final answer. By the way, your domain on this one would be all real numbers, and your range, although you're not asking for it, but your range would be y is less than or equal to a 1, 2, 3, 4, 5, a 5. Okay, less than or equal to 5. All right, next one. Inequalities. So at least we can leave piecewise for just a minute. Left 4, 1, 2, 3, 4, and then down 6. Puts our vertex right there. Okay, this one, again, we've got, if you remember from inequalities, we have a line underneath it right here. So we're going to have a solid line. And there is the A is 1, so it's up 1 over 1 in both directions. Up 1 over 1 in both directions. And so our line would go like this and like this. Okay, our function looks about like that. And it's less than. Less than, meaning I'm going to shade down this time. So shading down. And it's all the points that would be below our graph. Hopefully that makes sense. Last but not least, on number 10, first thing that I notice is that this is going to be a dotted line. Okay, dotted line when I draw it, can't forget that. I start off at a +5, +4. So we go over 5 and then up 4. And we put a dot right there. Okay? Now on this one, we go down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 in the other direction. Down 2 in the left 1. Down 2 in the left 1. So our graph will look about like this. Again, I need dotted line. So I'm going to connect all these with dotted lines. So it looks something kind of like this. And then on the right hand side, something about like this. Okay. This one says that it is greater than. So I'm going to shade up. Pick any point you want to, and you shade up from there. So we're shading all this stuff on top. Okay, all this stuff on top. And that is it. We can use our parent function and our new knowledge that we have to graph this a little bit easier. Okay, let's flip it over on the next page. Actually, the next page is what we're going to work on for homework. This will be your assignment. It asks for you to give parent functions, a couple different things. It also has you to describe some transformations. We've done that. We also have to graph some things just basically using the transformations that we know about. There are some piecewise functions. I love those. And then there are some inequalities as well. So if you have any questions, let me know. But this is basics of parent functions and an absolute value with Vertex form.